Hi, and welcome to our physics project.
For our project, we compared the light bulbs in 3 different areas. The first category we compared was the price of the light bulb in comparison to the lifespan of the light bulb. Here is our data.
As you can see, the incandescent bulb is the cheapest at $1.25 per bulb. However, this bulb's life is much shorter at 1,200 hours. If you want 50 hours of light, you'd have to go through almost 42 bulbs. That would cost about $52.03.
Compact fluorescent lights cost about $4, which is more expensive than the incandescent lights. However, these bulbs last 10,000 hours, which is 8 times as long as the incandescent bulbs. Over 50,000 hours of light, you would only need 5 bulbs and therefore only spend about $20.
The LED bulb is by far the most expensive bulb at $36 a pop. However, the LED bulb has by far the longest life at 50,000 hours. This means that it would cost you $36 for 50,000 hours of light a pop.
The halogen bulb costs about $7.60 each. Each of these bulbs lasts 2,500 hours. This means that for 50,000 hours of light, you would need 20 of them, which would cost you about $152.
So in terms of the cost of the light bulbs, you get the most bang for your buck with the compact fluorescent bulbs. Second place, you have the LED bulbs. In third place, you have the incandescent bulbs. The most expensive of these bulbs is the halogen bulb.
Though the cost up front is important, you must take into account the cost to operate each bulb.
Wait a second. LED bulbs are the most expensive.
No, I'm talking about over 50,000 hours. Like, if you had $50,000, you wouldn't need as many LED bulbs? Wait. Think about it.
Wait, so in terms of the cost of the light bulbs, you have the most? No, but halogen bulbs are less expensive than LED.
No, but if you're lighting it for 50,000 hours, you only need 1 LED bulb, and you need 20 halogen bulbs.
Alrighty, thanks, Andy.
Though the cost up front is important, you must also take into account the cost to operate each light bulb. So we tested the kilowatts of power each light bulb used in a 50,000 hour period and multiplied that by the cost of the electricity, which is shown here.
Since the incandescent bulbs uses approximately 3,000 kilowatts of energy in this period, the cost to operate the bulb is about $330, assuming that electricity is 11 cents per kilowatt.
The compact fluorescent bulb uses only approximately 700 kilowatts of energy over the course of a 50,000 hour period. That means that based on the assumption that electricity is 11 cents per kilowatt, the total cost of 50,000 hours of use from this bulb is $77.
The halogen bulb uses approximately 2,500 kilowatts of energy for over 50,000 hours. This costs about $270 under the same assumption about the price of electricity. This ends up being a slight upgrade from the incandescent light bulb.
The LED bulb only uses about 500 kilowatts of energy over 50,000 hours. Assuming that the electricity costs about 11 cents per kilowatt, the LED light only costs $55 per 50,000 hours of use.
When it comes to efficiency, in terms of cost and use, the LED bulb is slightly more efficient than the compact fluorescent bulb. Both of these bulbs are much more efficient than the halogen bulb, which is only slightly more efficient than the incandescent bulb.
In order to determine the most efficient light bulb, you must not only take into account the efficiency in terms of cost, but also the energy efficiency of each bulb. Here we measured the amount of power in the light bulb to the amount of brightness the light bulb produces. Here are the results.
So for the energy audit, I decided to do an energy audit of my house. And let's just say that my whole house is only using incandescent bulbs, and I'm not only using incandescent bulbs, it's just easier to do it that way. For lights at my house, it requires 500,000 watts per month just to light my house. And with 50 bulbs, that would be $460 a month to pay for lighting with just incandescent bulbs.
John Cook, come to the main office. John Cook to the main office. Thank you.
And if I were to switch to CFLs only require 4,600 watts per month compared to the 10,000 watts per month that incandescents take. And I would only have to pay $211.06 to light those. Now, if I were to switch to CFL, I would save $248.04 from incandescent. Now, if I were to switch to LED, LEDs only require 2,700 watts per month, which would come up to $124.02. Now, if I were to switch to LED, I would save $335.08. And this does seem like a great idea. Like, LEDs are really good, but because LEDs cost around $35 a light bulb, it would be really expensive to switch to all LED light bulbs. But in the long run, just like solar panels, the more you pay up front, it's probably, the money's gonna probably come back to you in a little bit. Thanks. Just keep going. Just keep going.
So, if you factor in the initial cost, the cost to operate, and the amount of energy used to produce brightness, it is obvious what light bulb is more efficient. Across the board, the LED was more efficient than the other bulbs, and overall, the most efficient light bulb. The compact fluorescent bulb was cheaper to buy, however, it takes second place to the LED, only slightly behind. The halogen bulbs were not anywhere close to as efficient as the LED or compact fluorescent bulbs, however, it proved itself to be slightly better than the incandescent bulb, which was by far the least efficient bulb out there. Physics 2012.